morning friends, my name is Dr.T Vamshi Prasad. I am working as an assistant professor in BVRIT, Narsapur. I teach us about the applied physics. Today topic is the Schrodinger time independent equation and wave function. Okay. Now you can see about the what is the importance of the Schrodinger time independent wave equation. Actually, in the Schrodinger time independent equation, we are taking about the concept of the de Broglie wave theory. In the de Broglie wave theory, the assumption is consider a particle of mass m. In the diagram you can see this is said to be particle mass m moving with velocity v at particular time instant t. Schrodinger time independent equation, one parameter is very important. That parameter is said to be wave function. The wave function represents about the particle nature and wave nature. It connects about the wave axis plus particle axis. So, in this time independent wave equation, the wave function is also the single valued equation. We can also find out about the probability density function. If the particle is moving along the xi and y plane, what is the mathematical notation for the probability density equation? In this, de Broglie concept is applied for the Schrodinger equation. We can calculate about the particle in one dimensional box and what are the physical significance of the wave function. You can discuss about the one by one. In this Schrodinger time independent equation, particle of mass m moving with velocity in space. Velocity means distance by time. Particle having the mass m. Suppose a system of stationary waves is associated with the particle at any point in space in the neighborhood of the particle. The wave equation is represented as equation number 1. In the equation number 1, we can see here the equation number 1, I am writing the mathematical notation as psi of r comma t is equal to psi of r exponential power of minus I omega t. This is said to be wave nature equation. So, the particle is moving along the x axis. I am writing here psi of xt is equal to psi of x exponential power of minus I omega t. If you differentiate equation 1 as dou psi by dou x, we can see first order dou psi by dou x is equal to exponential of minus I omega t into dou psi by dou x. If you differentiate the equation 1 twice with respect to x, you will get this equation, that is said to be dou square psi by dou x square is equal to minus exponential power of minus I omega t is equal to dou square psi by dou x square. We can write this equation as dou psi by dou t, okay, minus I omega t into psi of exponential power of minus I omega t. So, here differentiate equation 1 with respect to t. T means it is said to be time independent equation. We will get this equation. This is the one equation. If you differentiate above equation twice, we will get this equation. So, finally, we can write the above equation as dou square psi by dou t square is equal to v square into dou square psi by dou x square. You can rearrange the terms here, we will get this equation, and also we can write the equation above equation as in the similar way. After this equation, we have to write here what is the wave velocity. Wave velocity can be written as v is equal to frequency into lambda. We will write 1 by lambda is equal to wave frequency into wave velocity. Substitute the value here, dou square psi by dou x square is equal to 1 by lambda. See here, we will get the equation. After this equation, we have to write about the de Broglie equation, that is de Broglie wavelength lambda is equal to h by p is equal to h by mv. This is said to be our de Broglie equation. In this de Broglie equation, you can write here momentum p is equal to mass into velocity. So, what is the importance of de Broglie wave equation? The importance of de Broglie wave equation is the particle is not at all constant. It is moving with velocity v at particular time instant. That means the magnitude of wavelength is inversely proportional to the momentum here. The de Broglie wavelength, the magnitude of de Broglie wavelength is inversely proportional to the magnitude of the momentum. The momentum can be written as mass into velocity. H is said to be Planck constant. In this equation, substitute about the lambda as h by mv, that is said to be equation number 2. You can see here. So, equation 2 indicate for the lambda is equal to h by mv. You have to write h square m square into v square. After the equation number 2, if E and V is the total and potential energy of the particle. I am saying here E and V, this is said to be total energy, this is said to be potential energy. If E and V be the total and potential energy of the particle, the kinetic energy is expressed in terms of this equation. So, total energy is equal to kinetic energy plus potential energy. What is our potential energy? Potential energy is said to be V. What is our kinetic energy? Kinetic energy is said to be half mv square. Okay. Total energy is equal to E. So, total kinetic energy is equal to E minus V. You can see this equation in the mathematical point of view. So, total energy is equal to potential energy, total energy minus potential energy. After equation number 3, take the LCM, mv square is equal to 2E minus V. Square, add here m value, you will get m square v square is equal to 2m E minus V. So, square and m cancel together, you will get this equation. Okay. Squaring on the m on both sides, you will get the equation number 4. So, equation 2 is substituting about the de Broglie wavelength. Equation number 3 indicates about the total energy is equal to potential energy and kinetic energy. I am taking about the m square v square is equal to 2m E minus V. So, substitute equation number 3 in equation number 4. Substitute here m square v square value. Okay. Dou square psi by dou x square is equal to 4 pi square. M square v square value is 2m E minus V divided by h square is equal to psi is equal to 0. Simplify, you will get dou square psi by dou x square plus 2m E minus V, h bar square psi is equal to 0. See here h bar square. So, here in the quantum mechanic phenomena, h bar is h cut is equal to, you have to write h by 2 pi. In the quantum phenomena, we have to apply this formula, h bar is equal to h by 2 pi. We will get this equation. So, here dou square psi by dou x square plus 2m E minus V psi is equal to 0. This is the Schrodinger time independent equation. Okay. This is said to be Schrodinger time independent equation. Or we can write here equation as one more equation. See here dou square psi by dou x square plus 8 pi square m by h square E minus V psi is equal to 0. We can write in this way also, 8 pi square m E minus V. After this equation, we have to substitute h bar is equal to h by 2 pi. We will get this equation. In this equation, V is important. What is V here? V, it is said to be potential energy. If a particle has a free particle, it is a free particle. Free particle means the potential energy is equal to 0 in this equation. So this equation can be written as dou square psi by dou x square plus 2m by h cut square psi is equal to 0. If v is equal to 0, you will write here dou square psi by dou x square plus 2m by h cut square e minus e psi is equal to 0. There is no v here. Y become v is equal to 0. If it is free particle, the potential energy can be taken as 0. That is the one of the important point, key factor for the Schrodinger time independent equation. In the Schrodinger time independent equation, we are using the notation as psi. This is important in this Schrodinger time independent equation. This is said to be wave function. The wave function having the some limitations and also the physical significance is there. What is the importance of that wave function? The main point for the Schrodinger time independent equation, the wave function is the wave function having the particle plus wave aspects. It connects the wave aspects plus particle nature. That's why the wave function is modulated as a plane wave equation. The plane wave equation only we are deriving the equation, differentiating twice we will get this equation, and also after the equation we are substituting about the lambda, that is lambda is equal to h by p, substituting the de Broglie wavelength we are getting for mass into velocity. After the equation number 2 we are substituting about the total energy is equal to kinetic energy and potential energy, we will get the formula. After the substitute the 3 in 4, we will get the about the Schrodinger time independent equation. This is about the Schrodinger time independent equation. After this equation, what is the physical significance of the wave function? How it interconnects about the de Broglie wave equation to the Schrodinger time independent equation. So generally the wave function psi has no direct physical meaning. It is a complex quantity. The main point is it is said to be complex quantity. What is the importance of the complex quantity? So here psi as a complex nature, psi having a complex nature, that is it is a complex quantity representing the variation of the matter wave. Matter wave is nothing but is the dual character, dual property. It connects the particle nature and associated with wave nature statistically. So that's why it is having for matter wave dual nature. It connects the particle nature plus wave nature. So particle is represented as a position, time, mass and velocity. Particle having the mass, velocity, momentum and time. Wave nature. Wave is represented by the wavelength, frequency, amplitude and space. These 4 are important. Wave is represented as a frequency, wavelength, phase and amplitude. So what is the significance wave function? The wave function is used to identify what is the state of the particle. State means if the particle is moving along x-axis with respect to t, we have to write as x comma t. The particle is moving along y direction, we have to write as y comma t. The particle is moving along the x space, z space, you have to write for z comma t. So in the equation, the 3D complex, we have to write psi of the x, y, z as t. The wave function is used to identify what is the state. The particle is moving along x-axis, you have to write this equation. The particle is moving along y-axis, you have to write this equation. The state indicates about the to identify atomic structure. Point number 2 is psi into psi star. These indicate for probability density function. That means square of the probability density function here. This symbol indicates about the probability density function. This probability density function gives the total probability of finding the particle in the region of space along the x to x plus dx, y and y plus dy, and z to z plus dx. That means we have to calculate about the total probability of finding the particle in the region of space, that is x, y and z. Point number 3, total probability of finding the particle in the region is space calculated by the integral equation. This symbol indicates about the total probability, that means square of the total probability density in the region of space is given by this formula. Dx, dy, dz indicates about the volume element. So the total probability is equal to the normalized function is equal to 1. That means the total probability for the finding the particle in the normalization condition value should be is equal to unity, that indicate for 1. This formula is very important for the wave function. Next, if the particle is confined to along xy plane is important. The particle is moving along which plane? The particle is confined to xy plane only, then the probability to find the particle can be expressed as this formula. This formula indicates about the particle is moving along the x and y plane. Same formula for the normalization condition. If the particle is confined to only x axis, then the total probability value should be is equal to 1. You can see in this formula, I am representing only the x coordinate. In this formula, I am representing along the x and y plane. Same formula, if the particle is confined to yz plane, the formula you have to write for here y comma z. If the particle is confined to xy plane, you have to write here just z comma x. So in the different plane, we have to interchange about the axis one, that is components one, x comma y, y comma z, z comma x. So final point of view, the total probability should be is equal to unity for the normalization condition. Next, the wave function or complex displacement is a complex quantity. Very, very important point. That's why wave function psi is a real and complex nature. That is said to be complex quantity. So we cannot measure it. It is the mathematical point of view. We are writing about the wave function as the plane wave equation. We are differentiating and substituting in the mathematical equation. We are getting about the formula, but we cannot measure it. That's why only the psi is a real and positive quantity. Next, what are the limitations of wave function? We are having the different types of limitations. There are certain limitations to take psi as a solution for the Schrodinger wave equation. What are the limitations? Point number 1, psi must be finite values for all values of x. Very, very important point. Psi must be finite for all values of x. Next, psi must be single valued. Why becomes it is single value? Single value means for the normalization condition, the total probability value should be is equal to 1. For each set of x, y and z, psi must have only one value. That means the total probability value should be is equal to 1. Next, psi must be continuous in all regions except where the potential energy is infinite. That means psi must be continuous value in all the regions. The potential energy should be infinity. Next, psi is analytical. It possesses for continuous and first order derivatives. That's why we are taking for dou psi by dou t and dou squared psi by dou t squared. That's why we are taking for psi first order, second order. That means psi is analytical. It possesses continuous first order derivative. First order only, we are going for second order. Next, we are going for third order. Next, we are going for the fourth order. It is a derivative format. At the boundaries, the wave function must be vanishes. Very, very important point. If you take for particle in 1D box, the potential energy value should be is equal to 0. The boundaries, the wave function must be 0. This is about the limitations for the wave function. Okay, the limitations we have to see about the different points. Psi must be continuous, psi must be single value, psi must be vanished for the boundaries. Then coming to the next slide, you have to see about the what is the importance for the particle in one dimensional box. This is about the application point of view for the particle in one dimensional box. Here in this diagram, the particle will be located exactly inside the box. This is said to be particle in one dimensional box. So in the limitation point of view, the potential energy should be 0 inside the box. Okay, the wave function value should be here maximum. At the boundaries, psi is equal to 0 and V is maximum here. We have to, the particle is moving along the x-axis. We are taking about the, for the one end, the potential energy will be 0 to infinity. At the another end, the potential energy will be L to infinity. In this one dimensional box, we are calculating about the what is the total energy of the system and wave function. So here consider an electron of mass m, infinitely deep one dimensional potential box, that is total width is L, in which potential energy is constant and it is 0. The motion of the electron is constrained by the wall of the box as shown in the figure. This is said to be one dimensional potential well of infinite length, infinite depth. The particle is moving along x-axis. At the boundaries, the wave function must be vanishes. The potential in this box, the particle will be located in the box. That means the particle is able to move freely between 0 to L. When the particle strikes any one of the wall, it is reflected back as immediately. That means the potential energy of the particle must be changed from 0 to a finite value. The height will be nearly infinity. So in the limitation point of view, I am writing here two formulas. The particle is moving 0 less than x less than L. The potential energy should be 0. At the boundaries, the wave function not is equal to 0. One more category, if it is 0 greater than x greater than L, the potential energy must be infinity. So the wave function must be 0. So inside the box, wave function is not is equal to 0. Okay, very important point. If the particle is located inside the box, psi is not is equal to 0. If the outside the box at the boundaries, psi is equal to 0. This is the main difference. That is represented as equation number 1. Coming to the next slide, substitute the Schrodinger time independent equation d squared psi by dx squared plus 2m by h squared square e minus v psi is equal to 0. Here E is the total energy and V is the potential energy. In this equation, V is equal to 0. That means for a free particle, the potential energy must be 0. We will get the equation number 2. In the equation number 2, only take 2me by h bar square. Substitute some constant value, that is said to be k square. See here, k square is equal to 2me by h square square. So equation 2 means this equation can be written as psi of x is equal to a into sin kx plus b into cos kx. Equation 3 represents about the solution of the equation number 2. That means the wave function can be written as a into sin kx plus b into cos kx. Here a and b are and also k are constant. So equation 3 indicates about the general solution for the equation number 2. How we can solve this equation? We want to solve this equation, apply about the boundary condition. To calculate about the above values, it is necessary to consider about the boundary condition. What are the boundary condition? Boundary condition 1 indicates about the x is equal to 0, then wave function must be 0. If it is x is equal to L, the total length is equal to L, the wave function is also 0. That means the square of the probable density function value should be is equal to 0. Apply the first boundary condition in the equation number 3, we will get this equation. and also we will get b is equal to 0. That means psi of x is equal to a sin kx plus b cos kx. This is our equation. In this equation, b value is completely 0. We will get only psi of x is equal to a into sin kx. That is for equation number 4. Apply the second boundary condition in the equation number 4. What is the second boundary condition? X is equal to 0 and x is equal to L. You will get psi is equal to a into sin kl. Apply the second boundary condition only, you will get this formula. Okay, see here. Consider particle is present in the box and cannot come out of the box because the potential is infinite outside the box. Therefore, a cannot be 0. A cannot be 0 means we will get this formula. Sin kl is equal to 0. So, sin kl 0 indicate for sin kl is equal to n pi. In the general, in the mathematical point of view, you have to write kl is equal to n pi. So, finally, we will get equation 5 as k is equal to n pi by L. So, substitute equation 5 value in equation number 4, we will get about the psi of x is equal to a sin n pi x by L. Equation 6 is very important. Why? Become we are substituting psi of x is equal to a into sin k x. What is our k value? K value is n pi by L. Then only we will get for equation number 6. Okay. After the equation number 6, that is the total probability density function value. For the normalization condition, substitute about the total probability density function value should be is equal to 1. So, particle in 1D box, the main aim is we have to calculate about the total energy of the system and what is the wave function value. These two are important. Now we are calculating about the total energy of the system. Once the total energy of the system is quantized, we will calculate about the wave function also. See, this is the one of the probability density formula to apply about the particle in 1D box. What is our length? 0 to L. Apply the limits, substitute the value here. Psi is equal to sin square n pi dx by L. Take the a square as common. This is about the constant. Integral this equation. Apply the about the mathematical notation. See here step by step. Finally, we will get a is equal to root 2 by L. This is completely for integration equation. See here sin square n pi x by L. Integral formula 1 minus cos 2 n pi x by L. The lower limit is 0, the upper limit is L. Applying the limits here 0 to L. Okay, see here L, this value is completely 0. We will get a square L by 2 is equal to 1. So, a is equal to root 2 by L is important. Substitute a value in the above equation, that is for the equation number 6. We will get psi of x value is root 2 by L sin n pi x by L. So, equation 6 means a value is root 2 by L. This formula represents about the wave function of the particle in one dimensional box. But what about the total energy? That means what is the E value? To calculate about the energy eigenvalues of the system, go back for the Schrodinger time independent equation in the equation number 3. See here previously we have given one of the constant value as k square is equal to 2me by h square. Take that equation. Okay. See here substitute the k is equal to n pi by L. See here k square is equal to n pi by L. Squaring on both sides you will get k square is equal to n square pi square by L square. From equation number 5, see here substitute this value, you will get E value. See here in this equation finally we are calculating about the energy eigenvalues of the system. So, the energy eigenvalues of the system indicates about the E is equal to n square h bar square 2m by L square, or we can write the equation as this equation. This formula indicates about the n is equal to 0, 1, 2, 3. If it is n is equal to 1, 0 order energy. N is equal to 1, first order energy, n is equal to 2 for second order energy, n is equal to 3 for third order energy. That means the energy of the system must be quantized. That's why the particle is freely moving between x is equal to 0 to x is equal to 11. So, in this slide, two formulas are important. One is the total energy eigenvalue, one is the wave function value. See here, this is represents about the wave function for the one dimensional particle in a box and probability density in the particle in one dimensional box. See here, this is said to be wave function value for first order, second order. This value indicates about the wave function. Means in the two diagrams, if it is n is equal to 1 comma 2 comma 3, by using the above equation here, the energy eigenvalues of the system must be quantized. That means it is having for discrete values of the energy. See here, 1 indicate for first order energy. That means it is a lowest order energy. So, the electron will be any one of the above energy states for the eigen state for the given time. These energy values to be represented as energy eigenvalues of the system. So, yes, the probability density function you can observe here, two wave function value for the first order, second order and third order. Here also if it is completely maximum. In this slide also we have to observe about the nodes and anti-nodes also. One diagram indicate for the wave function value, one diagram indicate for the probability density function value. This is about the particle in one dimensional box. Okay, thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.